Hi, everyone. My name is Peter Boza, and I work with Vision Analytical. And today we're going to be going over some interesting size and shape information with a number of different types of materials that are used in the lithium battery market. The funny thing is, we actually came across this experiment randomly. So we were just kind of curious because one day we were looking at replacing some batteries, and we noticed that the size and the weight of these new lithium batteries that are out there in the market are significantly less and significantly smaller. As a matter of fact, we thought it was something was very wrong with this battery that we ordered because it was just so light. But in doing a little bit more information, a little bit more digging for information, I guess it does make a little bit of sense that lithium batteries are considered the best material for battery these days because they can provide a lot more voltage per area. So because of this, it takes up less space than conventional batteries or lead acid batteries of the past. They have more concentration and a lower self-discharge rate. So again, makes it ideal for all of these electric vehicle and different battery projects that are out in the industry. So what we did is we actually obtained some samples and we thought we would go ahead and do some comparisons because we were very interested. And we do know that particle size is very common for the lithium battery market, but we also started reviewing a little bit more into particle shape. So one of the things we did just to find out who's writing scientific papers is we go to Google Scholar, which is a nice source of kind of a benchmark as to what's going on in the industry with respect to scientific papers. And we've noticed that over the past years, there's been an incredible increase in the number of scientific papers being written on the importance of particle shape or morphology in the battery market. There are thousands of papers that have been written. So at this point, we decided to dig a little bit more, and we obtained five samples that are supposedly extremely common in the lithium battery market, and we decided to do some comparisons. So again, understanding that particle shape is very common. I'm sorry, particle size is very common. We ran this on a particle size analyzer, laser diffraction being the de facto default most common method to do particle size. And we did get some data that was comparable to what the manufacturer stated. In this case, about a 6 micron for this first sample, which is a lithium nickel manganese cobalt oxide. It's a cathode powder. When we did the actual particle shape analysis, obviously particle size is one of the measures out of the 32 measures that a particle shape analyzer would give. When we look at the volume weighted distribution, we get very similar results. We get about D50 of about 6.29 versus 6.18, very close in size. And then the reason we're bringing this up is because I think the benefit of particle shape is you actually get a lot more information. For example, we can actually show you the number weighted distribution as well. So if you wanted to see the presence of your fines, you can actually quantify the amount of fines that you had and actually see those particles. And then a couple other parameters that I wanted to bring up was circularity and smoothness. So circularity and smoothness are two measurements that are independent of size. And the reason we use those, and we're bringing this up in this presentation, is because circularity and smoothness are measures which are well attributed to the flowability, compressibility, compactability of powders. And the fact that these powders were not very round, not too round, one being very round, one being very smooth, we thought that having this information might be a good way of comparing the different samples, and we're going to do that at the end. So for these five different particles, for example, this first one, lithium, nickel, manganese, cobalt oxide, we have the data here, and we have some live running sample here where, again, this is a doing particle shape, which uses dynamic image analysis. We did the analysis, goes pretty quick. It took about a few minutes to run, and you get all of the statistical information, but you also get all the thumbnails. Having the statistical information allows you to do a lot of other things, such as looking at correlation information. You know, are the smaller particles rougher or the larger particles rougher or smoother? So those are some of the tools that particle shape is good for as a complement. The second sample, which seems to be very common for the lithium battery market, is this lithium manganese oxide. So again, another interesting very interesting curve here when you look at particle size. Again, somewhere in about the 10 micron range, DV50 of about 13.8. When we ran it on a particle shape analyzer, here we go, close to the same uh, distribution. Obviously, remember these peaks, since this is a number weighted instrument, this could represent just one or two particles when you get to the large size on a volume weighted distribution, but somewhat similar. Because of the irregularity in shape, you're seeing a little bit difference, 13 microns versus a DV50 of about 9.4. But again, here you get the ability to look at your number weighted information, how many fines, maybe the fines are important to understand. And again, slightly more round, which is actually interesting than the previous sample. And the smoothness is probably about the same as the previous sample. Here's a live view of the run of the lithium manganese oxide uh, cathode powder. And again, looking at thumbnails is a very interesting and entertaining function, but there's a lot more to it. And we're going to do those comparisons in a minute. And we'll show at the end how we can compare and contrast not only the size but also the shape. So going over the next sample is going to be a lithium ion phosphate sample where you can actually see that we have a very broad distribution. Again, running it on laser diffraction, the de facto method, you're going to run below a micron, which is about the lower limit of dynamic image analysis. But you get an interesting curve. You get some large particles here on this side as well. Again, looking at it as under the dynamic image analysis, you can actually see that we get some correlation with respect to getting toward the lower end, about a micron, and then we do have a peak that goes slightly over 10 microns. So definitely we get this as well. Once again, we have the comparison of number weighted information. So in this case, you can see we have a great amount of number small particles. And we can quantify that. We can tell you exactly how many particles are below 3 microns. And this is a very big benefit of using a number weighted system such as dynamic image analysis. Again, you wouldn't expect this if you looked at it on a volume weighted distribution, but this particle had a lot of fines in the sample. Again, looking at circularity, which is independent of size, slightly rounder, and smoothness somewhat close to the same. We move on to how we actually ran it, and you could see a lot of these smaller particles being brought out on in the sample. You see small little particles there. And again, you can actually look at the thumbnails as well at the end of a run, which is always good. But then you can also look at a lot of the other measurements, such as or tools such as classification, correlation plots, and things of that nature. We're going to go on to the next lithium particle. This one's a lithium cobalt oxide. So this lithium cobalt oxide is goes back to the standard just Gaussian curve here, about a 10 micron DV50 of about 10.2 with some fines here. So shows up some fines. Again, we're looking at about slightly lower in size, a different technique, but where the real compliment comes in is the ability to look at the number weighted distribution where you can actually see a lot of these particles that are on the lower end. And again, look at the circularity slightly on the rounder side. And this is interesting. You kind of have close to bimodal peak on the smoothness side. So that's actually very interesting. And then looking at actually running the sample, you'll see the video here of us running the sample live. And your data is here off to the right. And then when you're done, we'll do the sample in a few minutes. We ran actually even less than a few minutes. Looking at the thumbnails once again, you can see that there's some particles that are slightly clumpy, but then definitely, smoothness and circularity is something that is going to be affecting a lot of these particles. And then I think at the end, I just hit the correlation plot for everybody to see. And then going to the last sample, this one is not a lithium sample. This is a graphite powder. So this is used a lot as well. Graphite powders are used in batteries. And again, we get a lot of information here from these particle size greater than 10 microns. We can actually do a comparison looking at the volume weighted distribution where you can actually see that we do get some comparable information and we do get that small peak on the lower end. This one little peak here, again, being a number weighted system, will probably be just one particle. Again, this is where you see a big difference, is you'll see this large amount of fines. So a volume weighted distribution system may not see all these fines. This sample definitely had a lot of fines. Circularity, again, independent of size, we could see the comparison there. And smoothness, not as smooth, but actually pretty uniform, unlike the last one. Again, this one you'll see a lot of the little small fines all over the sample distribution, the sample screen here as we're running them. And then, of course, you're going to see that one big peak is this 130 micron peak particle that was sticking out, this one way out here. And you'll get to see all the particles, and you'll see that there's a lot of small particles. So then this is where I think the greatest value comes in. And the greatest value is looking at how the particles compare to each other. Looking at how they compare to each other by volume is very interesting. So this is a graph where we'll look at a volume weighted distribution for size. So this is a size ECA diameter, and we look at a volume weighted distribution, and we can see, this sample number 4, which is the lithium iron phosphate, definitely has smaller particles and than all the other ones. And we could see that the blue one, for example, which is the second one, is the lithium manganese. That one definitely has particles on the higher side. You can actually do the comparison also on the number weighted distribution. So this particle, which was the fourth one, the purple one, the lithium iron phosphate, you can also see that has the one that had the highest number of fines in the sample. So it has the highest number of fines and a lot smaller particles. So comparing by size is very important, looking at lot to lot differences, process differences, but it's always important to look at volume weighted information, but it's equally as important to look at number weighted information. In addition to that, the fact that we're actually doing shape analysis, we can actually do shape weighted information. So we can actually look again at circularity, how round a particle is, one being very round. We can actually see that the green and the red one, which is the sample number 1, which is the lithium cobalt, and the green one, which is the third one, these are the two that actually are the roundest of all compared to the other two. So you'll see that this purple sample, which had a lot of fines earlier, this is all independent of size. As far as their flowability, compressibility, that's something that's going to be independent of size. You'll see that these two are going to behave the same, and these two will probably behave the same. Looking at smoothness, which is the irregularity of the perimeter of the particle, we see something different here as well, where we see the red one has the lowest dip here, which has the highest percentage of the lithium cobalt, highest percentage of the smoothest particles, whereas everything else seems to be kind of like somewhere in the middle. These purple and the blue one, again, that do match here, also match here. So these purple and blue samples, this number 4, the lithium iron, and the number 2, the lithium manganese, seem to have the same profile with respect to shape circularity, but also have a similar profile with respect to smoothness. So I would expect that these two samples, again, size-wise, they were different, very different in size, but they're going to behave the same way, most likely in flowability and compressibility. So that's it. That's all I have today. I thought this would just be a really interesting comparison of showing this data. If anybody wants any information on anything specific to these samples, I'd be more than happy to set up a WebEx with them to show them a lot more information of each one of these samples. Thank you very much for your time and have a great day. And we could be reached at any time at my name, Peter, at particleshape.com, our website, particleshape.com, or call us or text us at this number anytime. Thank you very much.